Okay, so what happens if, let's suppose we start in equilibrium and injections over here, which we'll call J, are equal to withdrawals over here, which we'll call W. So the model is stable. Yeah, firms receive the amount of demand that they need from households have enough money to spend, and so on and so forth. Let's suppose there's a sudden increase in demand, though. Let's suppose that there is a sudden increase in tourism into the UK or something. Yeah, there's a big increase in the value of exports. So what's going to happen as a result of that? We now have a disequilibrium situation. So total demand has risen. Yeah, so firms, what they're going to need to do is they're going to need to increase output. They're going to need to, they're going to need to produce more goods and services to meet this demand from overseas. As a result of which, they're going to need more factor production. So households are going to supply more factor production to firms, and firms are going to pay factor incomes to households. So let's suppose there is an increase in demand of 100 million or 100 billion pounds. Ultimately, that 100 billion pounds is going to make its way back to households, either in the form of wages or rents, or ultimately the profits of firms belong to households. So households have additional income of 100 billion pounds through, as I say, wages or through profits and so on and so forth. Some of that will be saved, some will be taxed, some will be spent on imports. Yeah, we don't really know how much, but let's suppose that, for the sake of argument, let's suppose that 20% goes into those three and 80% is then spent. So what's now happened is that there is further expenditure by these households. They've received income, and now they think, great, I'll go to Legoland, I'll go to the pub, I'll do something. Yeah, so therefore, £80 billion is spent. So now firms have another increase in demand. Yeah, not just from exports, but the income that's been paid to households are now richer. They now demand other things inside the UK economy. As a result of which, firms will need to expand again. They'll need more factor production. This £80 billion will eventually be paid back to households again through wages or rents or profits and so on. So households now have another £80 billion. Yeah, different households, obviously, yeah, but they have more money. You have the landlords of pubs, Legoland, yeah, ice cream sales people. Yeah, they all have more money. As a result of which, some of that saved, but most of it will be, by these additional individuals, will be spent again. Say, in this case, we're saying about 80%. So another £64 billion is spent on different firms who now also need to expand, and so on. This process is known as the multiplier process. And what it's saying is that an initial change in demand, so an initial change in, we'll call it aggregate demand or injections and withdrawals, has a more than proportional effect on GDP. So our initial increase of 100 has led to GDP rising by 100 plus 80 plus 64, and is going to continue until eventually the impact of that injection has been cancelled out. As you can see, withdrawals are steadily increasing. When injections equal withdrawals, then again the model will be back in equilibrium. So this process, the multiplier, I think you can see fairly straightforwardly, that what it's going to depend on, how powerful it is, it depends on whether households do or don't spend their money. If these leakages are very, very high, then what happens is that firms pay households money, they save it all, that's the end of the process. If, on the other hand, firms pay households money and they spend most of it, that creates more demand, which creates more income, which creates more spending, and so on and so forth. So, if we look at what's going to determine the size of the multiplier process, then it basically depends on whether households do or don't spend their income. So we look at the multiplier. The key question is, do households consume the increase in their income? And the relevant concept here is called the marginal propensity to consume. And what the marginal propensity to consume shows is, if I give you an extra 10 quid, how much of that do you spend? If you spend 9 of it is consumed, then we say that the marginal propensity to consume is 0.9. You've consumed 90%. So out of every extra pound, you consume 90p or 0.9 of it. If, on the other hand, I give you £10 of income and you only consume 1 of it, most of the rest goes to the government in tax, or you save it, or you spend it abroad, then the marginal propensity to consume is only 0.1. And mathematically, not this matters, it is the change in consumption over the change in income. So, how does the marginal propensity to consume affect the multiplier? If we take those 2 examples, let's suppose in each case, so over here we'll have marginal propensity to consume 0.9, over here we'll have marginal propensity to consume 0.1, and we'll have £100 billion of demand. In this case, what happens is that there is an increase in income of 100 billion for households, and that leads to an increase in consumption of 90 billion. 0.9. That 90 billion is paid to firms, who pay it back in the form of wages, interest, profits, that type of stuff. So there is a further increase in income of 90 billion, which then leads to an increase in consumption of 81 billion, 0.9 of 90. That leads to factor incomes being paid of 81 billion, which leads to a further increase in consumption of 0.9 of 81, which is going to be 72.9, maybe. Let's hope so. And so on and so forth. The multiplier is clearly very powerful. In this case, the same increase in income of 100 billion leads only to an increase in consumption of 10 billion, which creates new incomes of £10 billion for households, but then they only spend 0.1 of that, so there's an increase in consumption of 1 billion, which leads to a further increase in incomes of 1 billion, which leads to a further increase in consumption only of 0.1 billion. The multiplier process has essentially ended. So whereas in this system, there's still £70 billion of demand circling around, here the multiplier has ended, because most of the increase in income has been saved or spent on tax or spent abroad. So the multiplier much will depend on, it does wholly depend on the marginal propensity to consume. And what that means is, do we as households tend to consume, in which case the multiplier process will be strong, or as households do we mainly tend to save, in which case the multiplier will be weak. And of course, different groups within the economy are likely to have different marginal propensity to consume. Generally, high-income groups who have most of their needs already met, they tend to have a lower marginal propensity to consume. So as a government, if what you were thinking about doing was trying to increase aggregate demand, a good way of doing that is to target increases in, say, tax cuts, for example. You might want to target tax cuts to low-income groups who have a higher marginal propensity to consume. Government spending, you might want to focus on taking unemployed people who have low incomes and giving them jobs, because they'll be inclined to spend most of it. So the multiplier, for what it's worth, you don't need to know this, by the way, but if you want to calculate the multiplier, you can do that. There is a formula. The multiplier is essentially a geometric series, and the sum to infinity of a geometric series is a over 1 minus r. In this case, the marginal propensity to consume is r. So the multiplier is essentially what we can say is that the final increase in GDP is equal to the initial increase in aggregate demand times 1 over 1 minus the marginal propensity to consume. As I say, you don't need to know this, it's just out of interest. So when the marginal propensity to consume is 0.9, the multiplier is 1 over 1 minus 0.9, which is 1 over 0.1, which is 10. So what would have happened is that the £100 billion worth of demand would eventually have led to £1,000 billion worth of GDP. Whereas in the case where the marginal propensity to consume was 0.1, that's 1 over 1 minus 0.1, which is 1 over 0.9, which is 1.1111. That multiplier, the initial 100 billion would only have, the initial 100 billion would only have led to 111.11 billion pounds worth of increase in GDP, barely more than the initial increase. So The model's quite useful then because it shows us what happens when there is a sudden change, either in injection or withdrawals, and it reiterates that point, that any sudden change in demand has multiplied or knock-on effects across the system. And that's the most important point about the circular flow of income model, and because that has major implications for policy. It means it suggests that if an economy is in recession, a small increase in government spending can actually have very big effects in the economy.